All right, we're going to be doing lesson 8.3 and 8.4 kind of combined here because we're going to be looking at shaded area problems. So we have been finding different areas of different shapes, and now what we're going to look at is what happens when you have something like a rectangle and they cut out maybe another rectangle in the middle of it. Okay? All right. So on number 1 here, find the shaded area. So what we're looking for is the area of the blue. Okay? And so just like we kind of were starting to set up in class a little bit, I want you to take the big outside object minus the inside object, because it's just like this little guy right here got cut out. Okay? So I'm going to kind of write this out. I've got big rectangle. That's my outside shape. And I'm going to subtract off a little rectangle or a small rectangle. Now, one of the things I'm going to go ahead and do too is just write down how do you find the area. So what's the formula, just so we're all on the same page. So we know that rectangle will be length times width, and we're going to subtract off the length and width. Okay? All right, so when I'm looking at the big rectangle, length 2x plus 6, width 4x minus 3. So I'm going to write those out, and then I am going to have to FOIL that. So 2x plus 6 times 4x minus 3. I got a minus in the middle. And then now I'm going to do my little rectangle. So 3x plus 5 and 2x. So I'm going to put the 2x out front times 3x plus 5. All right, so I'm going to go ahead and I'm going to start foiling this first part here. And so when I do that, I'm going to get 8x squared minus 6x plus 24x minus 18. So 8x squared plus 18x minus 18, okay? And now, since I can just distribute a negative 2x, I'm going to go ahead and do that, and that'll take care of the subtraction sign for me, okay? So I'm going to go ahead and take this negative 2x, and I'm going to drop it to both parts. So at the end here, I'm going to have a negative 6x squared and a negative 10x. And now I'm just going to go through and I'm going to combine like terms. So I've got 8x squared minus 6x squared, so I got 2x squared. Okay, and then so those guys are out. I've got 18x minus 10x, so positive 8x. So those guys are out, and then I have the minus 18 left. Now again, we are going to label whatever unit they give us. Again, if they don't give us a unit, we're going to put units squared. All right, so again, big shape minus little shape. All right. Okay, so now we've got the area of a circle, or we have a circle, and they've cutting out this triangle, okay? Now this guy right here, just to clarify, this 2x minus 3 is kind of like the radius and the base and the height, it's everything. So if I look from here to here, that would be the radius for my circle. It's also the base for my triangle. And then if I think about drawing up this way, this is also a radius, so this makes it also 2n minus 3. So both of those are going to be the same. All right, so I've got my outside object. So I've got area of a circle minus triangle. Okay, and the circle is pi r squared, and the triangle is 1/2 base times height. Okay, all right, so my radius was 2n minus 3. Now I'm going to leave pi in my answer, so I'm going to have pi there. I've got 2n minus 3 squared. I just replaced my radius. Minus 1/2. My base is 2n minus 3. And my height was also 2n minus 3. Okay. Now we know that right here, that squared means write it out twice. So I'm going to go ahead and do that. So I've got pi 2n minus 3 times 2n minus 3. All right. I'm going to go ahead and clean this one up, and then we'll take a look at that triangle. I'm going to distribute. Again, leave pi on the outside. 4n squared minus 6n plus 9, or 4n squared minus 12n plus 9. Now, you can choose to leave it like this right here, or you can choose to put the pi through. I don't care which one you do. So if you want to do that, it would be 4n squared, like pi, minus 12n pi plus 9 pi. Okay? All right, so now I'm going to go ahead, and on this one, I'm going to go ahead and FOIL this out. But the nice thing here is we've actually already done this problem. So I'm not going to sit and redo it twice. I'm just going to simply take my 4n squared minus 12n plus 9 and transfer it up. Okay, so I'm going to even draw an arrow here just so you remember where that comes from. So I still have the minus 1/2 out front, and then I've got 4n squared minus 12n plus 9. Now I am going to distribute that half through, so I'm going to take a negative half. So I'm going to have a negative 2n squared, a positive 6n, and then if you want to call this negative 4.5, negative 9/2, negative 4.5, it doesn't matter, okay? All right, so now, because of this pi symbol down here, so because of this pi, I cannot combine these guys with these guys, okay? So when I rewrite my answer here, I'm going to go ahead and have this guy, and then I'm just going to drop this in and say minus all of that. Okay, so it's going to look really long and complex, even though it wasn't really. So I'm going to drop in the negative 2n squared, the positive 6n, and the negative 4.5. Okay, now again, if you want to keep this guy right here, and you want to write it like this, I'm okay with that. Those are interchangeable parts. And then again, you'll have that second part. Now, we do need to label. And so again, since it's area, it'd be units squared. Okay, all right, let's take a look at the next page. Okay, so on this problem, it's a little bit different because we're not subtracting something out, we're actually adding, okay? So I've got a rectangle, and now I've put on a triangle, okay? To clarify on this 4x squared is actually the height, so this guy comes right in here, okay? All right, so this is going to be a little different, so we're actually going to be adding two objects together instead of subtracting. All right, and I'm going to go ahead and do area of a rectangle plus the triangle. We're adding on this one, since we're adding the two shapes together. So again, I have length times width plus 1/2 base times height. All right, so length and width, we know is 5x plus 3 and 2x plus 1. So I've got 2x plus 1 times 5x plus 3. So I'm going to FOIL that to 10x squared plus 6x plus 5x plus 3. And then clean that up to 10x squared plus 11x plus 3. All right, and now I'm going to go ahead and write in my formula for my triangle. So I have plus 1/2. Okay, base and height, doesn't matter which one goes first. I'm going to go ahead and do the 4x squared. And then I'm going to do the 5x plus 3 here. All right, so we're going to start by distributing this part, and then I'll take care of this half here in just a minute, okay? So I'm going to have a positive half, and I distribute, I get 20x to the third plus 12x squared. All right, now go ahead and let's distribute the half in. And so you're going to get a plus 10x to the third and a plus 6x squared. Now go ahead and start combining like terms. All right, so this is what I've got total for both my shapes. So we're going to go ahead and combine like terms. And I've got 10x to the third. So there's my third. I've got a 10x squared and a 6x squared. That's 16x squared. I've got a plus 11x and a plus 3. Again, because it's area, it's going to be units squared. Okay. All right, next problem. On this problem, real quickly for me, let's go ahead and label this. This will be like A, B, and C. Okay, now let's go ahead and read what's going on here. So Latanya's modular office is square. Her office in the company's new building will be 2 feet shorter in one direction and 4 feet longer in the other. A, write an expression for the dimensions of Latanya's new office. Okay, so let's think about this just for a second. If I'm thinking about that she has a square office, okay, I'm going to draw a couple figures here for you, but if I'm thinking square office, okay, hopefully we understand that all the sides would be the same. So if I call this like an x by x, okay? Her new office, so if I'm looking at her new office, will be 2 feet shorter. So if I'm looking here, 2 feet shorter in one direction and 4 feet longer in the other. So I'm going to subtract 2 off of one of them and I'm going to add 4 on the other. So her new office, so if I drew a new office here, So I've got 4 feet longer in this direction and 2 feet shorter in this direction. Okay? So that's kind of what my picture is going to look like here. Oops. Let's erase that real quick. All right, so A, write an expression for the dimensions of her new office. Now, when we say write an expression, I still expect you to always simplify. So I'm going to have x plus 4 times x minus 2. I'm taking her length times her width, okay? And then let's go ahead, we're going to clean it up here real quick. And I'm going to get x squared minus 2x plus 4x minus 8. So x squared plus 2x minus 8. Since we're talking feet, this would be feet squared. So this would be how much area she would be gaining or losing depending. All right, so now write a polynomial expression for the area of her new office. Okay, so actually that's what this is. All right, so this right here would have been my answer to A, and then this guy right here would be my answer to B. So we went ahead and simplified and already cleaned it up. All right, and the last part. Suppose her office is presently a 9 by 9. Will her new office be bigger or smaller? Okay. All right, so if I'm thinking about a 9 by 9, I'm going to go ahead and just kind of look at these pictures up here. Okay, I'm going to put it in here. So if I have a 9 by 9 here, 9 times 9 is 81. Okay, and if I put 9s here, I'm actually now going to get a 13, right? 9 plus 4 is 13. 9 minus 2 is 7. So I'm going to get a 13 by 7, which will give me 91 feet. So if I'm looking at these two, obviously her new office will give her more room. Okay. All right. And it says, and by how much? And we would end up with 10, 81 and 10, 91 or 10 units apart. So we're going to put her new office by 10 feet squared, or square feet. Okay? All right, and our last one. Now, we got to put our thinking caps on a little bit on this one. Okay, a homeowner is installing a swimming pool in his backyard. He wants its length to be 4 feet longer than its width, and so they've actually already set that up for you. Here's the width. 4 feet longer would be W plus 4. Then he wants to surround it with a concrete walkway of 3 feet, and so they show you adding 3 to each side. If he can only afford 300 square feet of concrete for the walkway, what should the dimensions of the pool be? Okay. All right, so we're actually going to be writing an equation here. Now, it doesn't change. We still have to do big guy minus little guy, right? Okay, because if I have my overall area here, and I'm going to take out the pool because we're not going to cement the pool. We're just going to cement the outside walkway here. So I'm going to still take big rectangle minus little rectangle. The problem is we don't have any dimensions for this big rectangle yet. So I've got to figure out what this guy would be. Well, if I know he's W, right? So from here to here is W. If I know it's W there, and I know I'm adding 3 over here and adding 3 over here, that would be W plus 6. So W plus 3 plus 3. So same thing going across here. If I go across this way, this is already W plus 4, and then I'm adding 3 on this side and adding 3 on this side. So 3 plus 3 plus 4 would be W plus 10. Okay. All right, so now to find the area, I'm going to take the big guy, the W plus 10 and the W plus 6, or area of my big rectangle. And I'm going to subtract off the pool. So let's see, on the pool we had a W and a W plus 4. Yep. So we have W and then W plus 4. All right, so we're going to start foiling. Now, I should go backtrack for a second. When it said here that we can only afford 300 square feet, okay? So what I have found right now is this is what my concrete is going to look like. This right here is how much concrete I have. And now I'm going to set it equal to 300 because I know that's all I can afford. All right, so now we're going to solve the equation. We're going to do some foiling first, though. So on the first part, we're going to have W squared plus 6W plus 10W plus 60. Or, oh, I put an X there, didn't I? Here, let's erase that. Yeah, maybe. All right, well, that's all right. So equals 300, sorry guys. So I get W squared plus 6W, 10W plus 60, and so that's going to end up being 16W plus 60. Okay, so now I'm going to go ahead and distribute my negative. Make sure you take the negative through, and I'm going to get a negative W squared and a negative 4W, and that equals 300. Okay, now, just like we talked about, W squared should cancel for right now. 16W minus 4W is 12W plus 60 equals 300. Subtract that off, so 12W equals 240. So W will equal 20. All right, so now the dimensions, I believe that's what it was asking for. What are the dimensions? Well, if we know the width is 20, so come up here and look at this. What are the dimensions of the pool? If I know this guy is 20, the W is 20, then I know that this side is going to equal 24. So I have a 20-foot by 24-foot pool. And that's my answer. All right, that concludes the notes for shaded regions in lesson 8384.